Hello, everyone. Can you hear me?
Just a moment. Yes, we
Okay,
can hear.
okay. First of all, my apologies for keeping you all waiting. I'm still traveling, so I couldn't be able to get on time to my destination. So my apologies for keeping you waiting. I was hoping you would talk among yourselves and do the revision, so we'll save time. But if not, we can get started right away because since we already lost time today. Did you revise among yourselves, or does everyone remember what we discussed last week?
Yes, some part of it.
Okay. Do you want to quickly summarize in 2 minutes the few key highlights of what we discussed last time?
Okay, last time we spoke about a 360 view of the customer relationship, the 360 view of the customers,
Okay.
about
Great.
the CRM, ERP, and other data capturing from the database. We get 180 degree of customers view, like what they bought and who, something like that. It will be useful for marketing. And also another 90 degrees, like using the data that we already captured, finding out who will be the potential customer. That is another 90 degree. And using their behavior, like through cookies, where they were waiting and what they were looking at, something like this. Then we capture another 90 degrees. So these all together becomes 360 degree of the customer view, that could be potential customers for us in future. So that's one
Very
thing
good.
we.
Yeah. So I sent out a poll. So actually, all the answers in it are right except for the weather information. So external data sources, such as social media data, your purchase, your credit card information, even though the company doesn't directly acquire it through the interactions with you, but they can purchase that information and link it to create a 360-degree view. That is also a potential data source. So social media is a data source. Your web browsing history, your click analytics is a data source. Your mobile app usage, whether you're using iPhone or Android, your IMEI number, which is a unique identifier for your device, that is also used to see if you're using the same device or if you're switching device. So any information that can be used that is related to you can contribute towards that full picture. So 360-degree view mean they have all the information about you, right? And we also discussed about the importance of complying with data privacy laws, because until a country has a data privacy law, it's perfectly legal to do that. But once the data privacy law kicks in, then it's a challenge because you just can't link all the information. So what is important is what's personally identifiable information. Any piece of information that can identify you is called PII. For example, even the IMEI number, which is the unique serial device number for your phone, which is linked with a phone number, can uniquely identify you because that phone number is linked with the bank account and I can easily make that determination. So PII is not just your first name and last name, but it's any piece of information. Even your IP address through which you're logging in and browsing could be PII. I have a static IP, so if they are capturing that IP address, it can be linked to me. So that is also PII. So many times there's a misconception that only first name, last name is PII, but it's not just first name, last name, which is PII. A good use case study for it is once Brad Pitt went to New York and he took a taxi ride. He didn't want to know anyone that he used the taxi ride, so he paid in cash, no credit card transaction, and he took a taxi ride. Yet, with data mining tools, using those surveillance security from the footage, what traffic was flowing, identifying where he took the ride from and which were the transactions which were cash, they were able to specifically pinpoint which taxi ride did Brad Pitt take in New York, on which date, from what time, from where to where, even though he used cash, right? So you have to be very careful when you're analyzing data to know that it is in compliance with the data privacy laws. Now, many companies, they will violate those laws, and they will keep violating it until the government enforces those laws as well. So as a good data architect, you should always follow good data hygiene principles, saying, do we have the members' consent to capture that data? Right? So just keep that in mind. So that's one good thing. Uh, we will today. What I wanted to specifically discuss was, how does the data flow and the importance of ODS and data warehouses. And then in the subsequent discussions, we'll talk more about data integration. I think, Tapesh, you had posted some questions related to data integration. uh, I won't be able to do justice by just answering it in few lines on the WhatsApp group, because that topic itself, the topic of data integration, will need 2 3 sessions if I have to cover it completely in depth. So just hang on, we'll definitely cover it. But to understand data integration, you have to understand what is the flow of the data, how data flows across the organization. Does anyone remember the definition we talked about? What is data architecture? We covered that in the first and the second session.
Data production and the movement of data, then consumption of data.
Yes. Yeah. So in order to do that, we need to know how the data flows, because then we can design each and every aspect of the data, how the data is modeled, where the data is produced, how the data moves across systems, and how does it gravitate in the data lake, and how is the data consumed. All these aspects are data architecture. So absolutely, data integration is one of the key pillars of data architecture. Since we're on that topic, I'll give you a short answer, but please don't memorize that answer, because it'll easier to trip as well. Data integration is about data movement, and there are primarily 3 ways you can move the data. You can move the data in batch or bulk. So you create a flat file which has 10,000 records. That is bulk amount of data, right? Because it's not one record or two record. It has 10,000 records in one file. That is bulk data. And that is batch movement of data. You'll specifically use that bulk data to move it once in a day. So you'll create a file extract, you send it to another external entity using secure file transfer protocol, or SFTP, or you'll use it internally by dropping it off in a file share. But that's one option. The second option is you're exchanging that data in real time using APIs. APIs, application programming interface. But typically, you can exchange. There's something called as a bulk API. But typically, you wouldn't want to do bulk API. You would do it per record. So an example of that would be get customer. So you'll say get customer with this customer ID, and you will get all that information in real time. And that information could be coming from a data lake or any other data source. And the third one is streaming data, right? So you've got patient data, it's streaming, weather data, it is streaming, and you're pulling that using a REST API as well. But primarily, when you're integrating data, you need to know whether it's real time, whether it's batch, what is the latency, what is the delay. Latency is nothing but the delay in the data from the producer to the consumer. How much of that data is acceptable? Old mentality, old data architect who hasn't updated him or herself, they'll say do everything in batch. A new data architect who doesn't have a lot of past historical experience will say everything in real time, right? A good data architect would validate the use case. Not everything needs to be in real time, not everything needs to be in batch. When to use batch, when to use real time, that's a decision a good architect will take, instead of saying use real time for everything, use batch for everything. It doesn't work. We have to evaluate it case by case, and we'll cover those cases as well, right? But those are primarily the 3 techniques, and which tool you use accordingly, you have to determine that. If you're using bulk data movement, then you will use an ETL tool like Informatica Power Center. If you're using cloud, AWS, you will use AWS Glue. If you're using Azure, you will use Azure Data Factory. The reason why I'm mentioning the tool names is because as an architect, the expectation is not that you need to know everything about Azure Data Factory or everything about ETL. No, a little bit about everything. Even if you can just mention the name of the ETL tools, that's good enough. Yeah, that shows that you got that experience. APIs, nowadays, API gateways are used. Apigee is one of them. Azure has its own gateway called APIM, Azure API Management Gateway. AWS has its own called AWS API Gateway. And then for streaming data, you will use some streaming service. So Azure has an IoT hub or an event hub where you're just streaming that data. But don't worry, you don't have to memorize this. I'm just mentioning this so at least Tapesh can get through his interviews and not have to wait for a few weeks to get a detailed answer. Okay, so we'll start with what I wanted to discuss for today. But any questions from the previous session or anything specifically you want me to discuss today? Because then I can definitely swap the agenda as well. Okay. If not, then let's jump into it right away. So as I discussed last time, right, the reason we discussed Customer 360 was to make sense, why do we do all this, right? So we all understand the importance of creating a Customer 360-degree view, why we need to create it, and what does it mean? So in nutshell, to create that Customer 360-degree view, I need to have access to all the data. There are two ways you can have access to all the data. Option one, all right, is you got data. Let's take the simplest use case. You've got three internal systems, your CRM, your ERP, and your MDM. Does anyone remember what is MDM? Full form for MDM?
Master data management.
Perfect. Yeah. What is CRM? Full form of CRM?
Customer relationship management.
Perfect. And ERP?
Enterprise resource planning.
Perfect. Ramesh, you've exceeded answering all the questions correctly. So I want others to answer today, but thank you for doing that. So I want to make sure everyone else is participating too. So we've got multiple systems in IT. There's like as
Sorry,
Ramesh,
not many people in today, so I'm just answering. Sorry about
yes.
that.
No. I appreciate it, but I want to make sure everyone is inspired by you answering, and they also are able to answer as well. But I'm glad you answered it all correctly. So in an organization, there are multiple IT systems in which the data is fragmented or scattered across multiple systems. In order to create that 360-degree view of data which is scattered across multiple systems, there are two options. And those two options is pretty much what defines the data strategy in an organization. One option is you virtualize your data sources. Virtualizing your data sources means your data is where it is in each of those systems. Your data is in CRM, your data is in ERP. You create another layer which gives the view of all the information across those systems. But you're not actually moving all the data to create the view. The data still resides in each of those systems. You're just creating a front end which is getting that information from each of the system one, system two, system three. So you're creating a virtualized view of that information as if it was in one data source, but it is actually scattered across all systems. Everyone clear what is data virtualization, or what does virtualized data source mean? Virtual data source means it gives the impression that these four systems are actually one system, because you are accessing not four different screens, but you are accessing one screen which is connecting to those four data sources. Now you can create that view in a reporting tool like Tableau, Power BI, right? And have those data sources. Let's say I have three systems. I will create those three data sources within Power BI or Tableau and create this view which says, okay, show me all the customers' past transactions. what is the profile for this customer? This customer is a rich customer, or this customer is, doesn't have a job, is probability of them making a high value purchase extremely low. So give me the profile for this customer. Now, when it's calculating all that information, getting the purchase history, the purchase history is coming from a transactional system like SAP. The profile, what is the propensity? In data science, we use the word propensity, or the likelihood for this person to make a high value purchase. That is calculated by the data science or data analytics team. That value is residing somewhere else. But I'm creating a report which shows me all this information. This person has a job. This person has an iPhone. This person, is a regular buyer. So I can create that profile, but everything is in one page. I'm not clicking 4 different screens. So I can, when I'm talking with the customer, I have all the information I need about that customer. So that's one option. Usually it works out well. There's only one problem with that approach. The problem is, every time you are adding a new data system, you're adding a data source, each system has its own identifier for that person. And you have to understand what is that unique identifier, and this identifier in the system is for the same person. And then you have to link it to this dashboard, right? That's one piece of work you have to do. But most of the time, the challenge is, every time you're doing all this work, it is actually going and getting the data from the data source. Right? Now, is that a problem, that if I'm getting my data from where the data is that a problem, or should I even be concerned about? What do you think? Yes, right, wrong doesn't matter. Why should getting data from a data source, which is the system of record where all the information be there, be something that I need to think about or even be concerned about?
Because it has to be updated on a regular basis. If it is not, then it will give us a backdated data.
Yeah, but the data is there in that source, right? So if customer updates any data or anything, it's a transactional data source. So it'll have the fresh view, it'll always have the latest, greatest data, in fact. Correct? What else could it be that we need to worry about? So let me give you the answer, because you may not be aware. But the reason we need to be concerned with that approach is, the purpose of that system which has that information, the purpose of, for example, the CRM system, is to capture the customer interactions. That is the purpose of that system. To fulfill that purpose, it's storing the data within its database, right? Remember, we said a system usually has a front end, has its own database, and it's a full application. So CRM, like Salesforce, it's a own application. It's a whole system. It has its own front end, it has its own middleware API layer, it has its own database. But the purpose of that system is to capture customer interactions and store them. The purpose of that system is not to be a virtualized data source for other use cases. And the reason why it is concerned is because anytime when you run that query and you're getting that customer information, it is going to run a query on that system, and it's going to take that resources on that system. Now, if it's just one customer record, nothing to worry about. I don't even have to think about it. But in reality, it won't be just one query in a day or one customer. It will be thousands of customers. Someone would be using that dashboard on an ongoing basis, and it will add to the transactional workload on that IT system. That transactional workload on that IT system will eventually impact the performance of that transaction system. This is a very important concept, and because of this concept, I'll be able to tell you a lot more things because of the same reason. When you are adding other transactional workloads on an IT system, which is not the sole purpose of that IT system, you are adding more performance load on that system, which will eventually impact its performance. This is very important to understand. So I want to make sure you agree with this statement and you are convinced that that is true. Do you all agree? That does that make sense? Or it
Yes.
doesn't make sense?
Yes, it
Yes,
does.
it does. Okay. This is very important. I'll give you an example just so that you remember it, right? For confidentiality reasons, I won't be able to give the name of the client and the system, but I'll give you an example. We had one system which was worth few $1 million. The purpose of that system is primarily to capture the patient interaction every time the patient visits the doctor. That's an EHR, electronic health record. That is the sole purpose of it. So every time you visit a doctor, the doctor is taking notes. Okay, why are you feeling headache? Since when are you feeling the headache? Did you vomit? And he or she will ask so many questions. All that information is recorded in an electronic health record or an EMR system. There are multiple EMR systems. So that's the purpose of that system. Now, over the period of time, we had reporting needs. Oh, I need this information. I need that information. And we started doing more and more reporting on it to the point where it takes hours to generate a report because the system is so heavily overloaded that you would say, well, just a report is nothing but few queries. Just run the query and, it should be done. But it takes hours to generate the report because that report is not for one person. It is for all the patients. And that report is joining multiple SQL queries and doing other things. So the workload was so heavy that it first of all took hours to generate those reports. And second of all, every time those reports were being generated, the system will become so slow and you would feel that the system performance is severely degraded. So that is the reason why many organizations, they don't want to do operational reporting from the transaction system, even though the operational data exists within the transactional system. So for example, I have a POS, point of sale. So when you're going to a shopping mall and you're making a purchase, you swipe your credit card, the person is saying, okay, you bought this, they use the barcoder. All that information feeds into a point of sale system. The most common one in US, I don't know much about India, but in US, there's a company called NCR. So just Google for it. So if you want to build your own POS system, multiple clients, they use NCR, right? So a lot of grocery stores and retail stores, gas stations, they use NCR POS. They will they will run all those transactions through that system. That NCR system has all the information about the transactions, how many purchases were made, for what amount, where, in which store, every detail is there within that system. If I want to run an operational report, how many customers bought how many dollars worth of products at this particular store, that's an example of an operational report because it's telling me what happened day to day, right? Just like in an operation theater, the physician is focused on what's happening in the moment, what's happening right now, right? The physician is not asking, why your lungs are bad. Did you smoke or, did you have COVID? That's past. In the operation theater, the physician is just focusing on what's on hand. Same way, when you're doing operational reporting, you're not concerned about what happened with that customer purchases 5 years back. That is historical or analytical data. I think we covered this, but I'm just repeating it so that you're absolutely clear between operational reporting and analytical reporting. Because many times the business or product will come and say, I need report. My first question is, do you need an operational report or do you need an analytical report or historical report? And many times they'll say, well, I don't know, or does it matter, right? That's usually the counter question. I was like, yes, it absolutely matters in terms of the scope of the effort to build and design that report. Because if you're using analytical report, it's a different data source. If you're using operational report, it's a different data source. So it matters. Just creating a report, or not all reports are equal. So in this case, right, in the POS, I've got all the data I need. I could certainly easily run that operational report on that POS as well. Yet, I'm not running that operational report of that transactional system for the reasons we discussed. So anyone wants to summarize why do we don't want to run that operational report from that transactional POS system?
Yes, I could add a few more points to that.
Yes, please.
As you suggest, I could see that operational reporting from the online transactional data. There is a possibility having the dirty data coming into your virtual dashboard because it's a
Yeah.
transactional system, and when you're fetching the data from
I'm not able to hear Rupali. I don't know if it's my internet
particular
connection.
application from where we are fetching the data.
Okay, I lost what you said,
Which is
Rupali, for a few seconds, but certainly that's there for sure. So Salesforce, as an example, also provides capabilities to do operational dashboards and operational reports, right? Now, Salesforce is a software as a service. Remember, the rationale behind not doing operational report on that system was that it's going to impact the performance of the system. However, right, for a software like Salesforce, if Salesforce is saying yes, it's not going to impact the performance of the system, it is my guarantee, then it's perfectly okay to build that operational dashboard because that's on the cloud, and on the cloud, you get the elasticity. So that's another good example where I don't want to create a blanket statement saying never do operational reporting on a transactional system. Not true. What is important is the rationale or the reason why we said that. Because if you're going to the cloud and in the cloud you've got sufficient resources and it's not going to impact the performance, then it's perfectly okay. However, we know that it has the potential to impact the performance of the transactional system. So what Salesforce does is it puts those controls or the guardrails as to how many queries you can do or how long running the query is, because if you don't follow those controls, it will impact the performance of the system. So even though you can do operational reporting with Salesforce, there are some controls called the governor limits which enforces what you can do or to what limit, so that the rationale same, the system performance is not impacted, because on that same infrastructure for Salesforce, it's got thousands of clients. And if all of them are running operational reports to its peak, it will bring the system down. So just something to be aware of. So the problem statement is, let's say, to be very specific, I have a virtualized server. My IT system is using virtualized servers on the cloud. It has all the transactional data in it. Should I do operational reporting of the transactional system? Yes or no? It is all virtualized machine on the cloud.
Yes, I think.
Should I run the operational report?
Yes.
Okay, if we run it, then it will impact the system performance. Then my VM will start hanging up. Then in that case, I have to vertically scale the VM by adding more virtual cores or more memory to it. So yes, I can do it with the caveat that I may have to vertically scale the VM, but that will be to a certain limit, right? Because I can keep adding more bigger and bigger VMs. It's going to add to the cost, and at some time, it's not really the number of CPUs or anything. It's just overall it's impacting the system performance, because now I've got too much data that otherwise I could have purged, and it impacts the system performance. So just something to be aware of. In general, the design principle is to avoid such issues and constantly trying to vertically scale and monitor the system performance and everything, especially if you've got a large enterprise with 30, 40, 100 IT systems. If you're doing operational reporting on those 100 systems and monitoring the performance usage of those VPs or those VMs and adding virtual memory and cores is going to be a nightmare. Organizations, they don't want to do that, right? So one option is, if you got such a complex system of IT systems within the organization, right? Get the data, operational data, out of the transactional systems, purge the data or delete the data. Don't keep it for 10 years, right? You keep it for 3 months, 6 months, 1 year at the most. But after 1 year, you can safely delete that data because you're making a copy of the data from that transactional system into another system, right? So you take a copy of that transactional data, the POS data in the example, and you constantly make copy of it and put it somewhere. Now that system, that database where you're putting all this copy of the data, the sole purpose of that database is to meet operational report. That's it. So even if you can scale up that virtual machine, but you won't have to scale up that much because all you're doing is just operational report, right? So you don't have to monitor all the time, right? That's one advantage. Second advantage is, you're not going to, if you, let's say you had 100 IT systems, you're not going to create 100 databases, right? You'll probably create one big database in which all the data from those 100 IT systems will flow in one place, and you can do operational reporting over there. So that way it becomes easier to manage that operational data because it's in one place. So coming back, remember we said there are two ways to create that view of the data. So one is you keep the data where it is, but the risk is you will impact the transactional performance with data virtualization. The other option is you consolidate the data. You make a copy of that data, you move a data and keep it all in one place. That is data consolidation, right? So you keep all the data in one place, and then where you have it in one place, you use it for operational reporting, you use it for analytical reporting, and so on, right? Because the purpose of that consolidated data is, when you bring that consolidated data in that one place, it's not going to impact the performance of the transactional system. Those are the two key ways you can design the system. So one is data virtualization, where you are virtualizing your data source. Nowadays, there are data virtualization tools in the market, which is essentially, making it easier for you to virtualize your data. Example for that is Denodo, Denodo. So in interview, if they ask you, have you used any data virtualization tool? Say, yes, I'm familiar with Denodo. You don't have to say I'm an expert in Denodo, right? I am familiar with Denodo, which means I know a little bit of everything, not a master in it. And say, what do you know about it? Say, well, I can virtualize data sources. It uses a Java type language, and you can talk about it for 2 to 5 minutes. That's good enough, right? Just watch some YouTube videos, and you should be fine. You should be able to clearly clear the interview that way. Most of the organizations, they will go for the data consolidation route. Usually when I'm advising clients, I'll go for the data consolidation as well. Only in certain exceptions, data virtualization would make sense. Those exceptions are, if you've got data in a system where it's very expensive and time consuming to get data out of that system, to analyze that data. Many times what happens is you acquire a company, but they don't have good documentation or understand who wrote that code and do what. So they don't want to touch anything for it. So even to get that data extract out, they are worried that if they do anything, it will break, right? Because they may not even have all the entire source code for it or anything. Another example is you got mainframe data. They don't want to really touch it. So in cases where it's not easy to extract data out of that system, uh, because it's not easy to extract it, or it's because you don't understand the format of that data, or you don't have the resources to do it. In that case, virtualization makes sense. The biggest drawback of virtualization is that, yes, you can certainly use virtualization for reporting, but when it comes to data analytics, where you need batch data, you need a lot of bulk data, then virtualization has a severe drawback. For the same reason, when you're running few queries on that system, it's fine. But when you run bulk queries and you're getting that batch data out of that transactional system, whether your reporting layer was putting that load or whether your virtualization server is putting that load, someone is putting that load on that system, it will impact the transactional system's performance. That's why data virtualization tools have limitations and they're very expensive. For example, Denodo licensing fee is $400,000 a year, right? So the cost of consolidating that data is a lot cheaper than spending $400,000 a year. So why would I spend $400,000 a year for the licensing fee when I can consolidate all that data in this one system that we call it as the data lake? Clear so far? Any questions?
So what is the last word? Is it data? Bringing data to a single system.
So that is data consolidation, and that single system where you can consolidate all the data is called a data lake. So that is the most common preferred data strategy, is you consolidate the data. So you have only two options: virtualize your data or consolidate it. In some cases, they'll use hybrid, but it doesn't make any sense, right? Why do you want to have a virtualization tool and you have a data lake as well? The reason why it made sense for one of the client was because it was a financial client, because of countries' data locality laws. Like in EMEA, in Switzerland, if you have a financial client, Switzerland says you cannot, if you capture any data within Switzerland, you cannot move it out of Switzerland, period. You cannot move that data out. Do whatever processing you want to do and everything, data originated in Switzerland, it will stay in Switzerland. That is the Swiss law. So in that case, what they do is they'll say, okay, I've got my data in North Americas. I will use my data lake as a virtual data source to connect with the data in Swiss. But that virtualization would happen in the Swiss region. So that way, if I want to join reports saying which are my high net worth individuals who have a portfolio in Americas and who have a portfolio in Swiss, I need to join those two data sources. So that join is happening through a virtualized query. The North Americas is a virtualized data source, and it's joining it with the Swiss data source, which is in Swiss. In that case, we had a hybrid approach because of those data locality laws. India does not have any data locality laws yet, but they're pushing for it, but there's no laws like that, which means Facebook and other companies, Amazon as well, they can generate all this transactional data, move it back into US and join it over there. But if India introduces those data locality laws, then they can't do that, which is a good thing for India. But they just, I don't know why they take so many years to implement those laws. But those laws don't exist yet, which means you can move all the data out of India and put it wherever you want and consolidate the data. Makes it easier for a data architect to do his or her job because you can just consolidate all the data. Yeah. Okay. So data consolidation is preferred over data virtualization. The reason is because it's cheaper to consolidate all the data in one place. Second, you can use that consolidated data for multiple use cases, in not restricted to reporting, but you can use that data for analytical use cases. You can expose that data as an API as well, and essentially you can evolve that data lake into a data hub. So all your data needs can be met potentially from that data lake or data hub. Right? So think of it this way, right? What is a hub? Hub is a central place where you'll find everything you need, right? So here you go to the data hub and say, I need customer information. You'll get it. You'll say, I need my product information. You will get a copy of it. So you don't have to figure out which are the data sources, where should I get it, because a lot of the engineering time when a data architect has to figure out what are those data sources and where the data is. This way it simplifies the data access. And this is where Gen AI use cases come in picture as well, because now with Gen AI, you have data assistants where you say, okay, I need customer information. Where should I get it from? Right? And the chatbot will respond saying, oh, it is in this data catalog. This is the schema for it. Go and get it from here. So now data discovery makes it a lot easier to access your data without trying to figure out where all the data is, because that has been a challenge for years, for decades. Because as the complexity of your IT systems grows, so are the number of IT systems growing, and so is the complexity of data, because your data is scattered all over different IT systems. Now, let me go into the past again to tell you something more about the evolution, because then it will make sense, right? So I will go back 15 years in the past. So this problem statement existed 15 years back as well, that if you're running operational reporting or if you're running use cases, your transaction workloads, other than what's needed to run that system, it is going to impact your performance, because that's how databases are built. It does what's called as indexing, and if you don't purge the data, if the amount of data keeps increasing, it's going to take longer to search for that specific record, right? If I have 100 records and if I have to find that one orange among those 100 oranges, it'll take some time. But if I have to find that one bad orange among 10,000 oranges, it'll take a lot more time. So as the amount of oranges or the amount of data increases, finding that specific record is going to take more time. So why keep those 10,000 oranges or keep those 10,000 records from past 10 years in that system? Yes, you need to keep it for analysis, but it doesn't need to be in the transactional system. You can move it outside of the transactional system and just keep, what's bare minimal to have optimal performance for that system. So this problem existed 15 years back as well, right? It existed even 20 years back. How did organizations solve it then? That time, there was no concept of data lake. So the way organizations solved that is, they said, well, we'll get the data out of the transactional system, we'll put it in another database, and because the purpose of that database is operational reporting only, we'll call it as operational data store, or ODS. So ODS is nothing but a copy of your transactional system data within that ODS, which has all the operational data from which you can do operational reporting. Okay? So that solves the operational reporting problem. Okay? Then the next problem statement is, that solves the operational reporting data problem. But what about historical or analytical reporting? What should I do that? Because if I keep all my operational data on that ODS and never purge or delete anything, it will eventually then have not only operational data, but it will have analytical data as well. And then if I have both operational and analytical data, the same problem will occur, because I've got too much data than I need and I'm just using it for operational. So what should we do then? Take a guess. Logically, what would you do? Right? You got the same problem. You just shifted the problem from the transactional system to the ODS. So if you're putting everything from the transactional system to the ODS, which includes operational data and analytical data, will it impact the performance of ODS? Yes or no?
Yes.
Yes, because the same problem. You got too much data. And by definition, operational data is just data which is like 6 months or 1 year old. 5-year-old data is not operational data. So you got unnecessarily data that you don't need it, right? So one option is, what are my options? One option is I delete what I don't need, or I make, as the data gets old, I move it from the ODS into another database which will have all the historical data. Would that work?
Yes.
Yes, that's what they did. So that operational data store has operational data. You make a copy of that operational data, put it on another database. That database is called as a data warehouse. So data warehouse typically has one second. So data warehouse has all the historical data. ODS has all the operational data. Clear so far? So data flows from an IT system into an ODS, and then from ODS, it flows into the data warehouse. And you can have multiple ODSs, and you'll typically have one data warehouse where all the data across transactional systems or ODS will gravitate to the data warehouse. In some cases, they may not need operational reporting, or they are okay with the minor performance hit because their operational reports are light, right? So the assumption was it's going to impact the system performance. But if my report is so light that it doesn't impact the system performance, it's okay. But it does impact the system performance if it's analytical report. So some organizations, they'll say, well, I don't need ODS, but yes, I need analytical or historical reporting, or they'll simply just say reporting, and then they need to send that data to the data warehouse. So essentially, that data warehouse is your data reservoir where you're collecting all the data, or your data is gravitating towards the data warehouse. Clear so far? So the concept was the same. There is a need to consolidate the data, but how the data flew was different, and it went from an ODS and then it went to a data warehouse. That's how they did it 15 years back. So 15 years back, it was all relational data only. So do you think there would be any JSON object in a data warehouse?
No.
No. Why? Because data warehouses were nothing but a database meant for storing analytical relational data. JSON XML came after 2010. That time, we weren't even capturing or storing that data because we wanted relational data. By definition, JSON XML is semi-structured data. Data warehouses were never meant or designed to store semi-structured data, right? So data warehouses were storing relational data only. So Teradata was like the king. If you want a data warehouse, you'll either use Teradata, or you'll use Oracle Data Warehouse, or in some cases you would use Microsoft SQL Server as a data warehouse. Those were the pretty much three options. Of all the clients I worked with, mostly all of them used Teradata. Some used IBM Netezza, some used Oracle Data Warehouse, some used Microsoft SQL Server. But that was pretty much the choice. And those were the choices that existed for more than 20 years. So if you want data warehousing, you're probably using Teradata. So you need to know what is the high level architecture of Teradata, and how Teradata works, what is BTEX server, what is a Unity server, blah, blah, blah. Fortunately, I don't need to go into those details of Teradata, because now clients, they're migrating away from Teradata and moving into the data lake. So there's no advantage in learning all that, because it won't help you in the job. But yes, if you want to learn, again, just Google it in YouTube. You'll find plenty of stuff. If need be, I can cover one session on Teradata. But most of the clients that I know, they've already migrated, or they're almost about done migration from Teradata, because Teradata is too expensive. Right? They didn't keep up with technology, and they just made a lot of money. So they're now obsolete. But for you, more than 2 decades, they were like the king. Anything data warehousing, Teradata, first choice. Okay. With that, I think we covered quite a bit. We covered what is ODS. We covered what is data warehouse. We covered the need of ODS. We covered difference between ODS and data warehouse. And we briefly introduced what is a data lake. But of course, I'll continue the evolution of how data lake came in, why it came in, everything, because that historical context will make a lot more sense. And you'll be like, okay, this makes sense. Otherwise, if I just tell you what data lake does, you'll be memorizing it. But this way, you will have the concept and you'll understand why things are the way they are, because there was a reason why it is the way it is. So that's why it's important to cover that historical context. Again, my apologies that I kept you waiting. So any questions so far?
Where does the data mart fits into the picture?
Data masking, is that what you're asking?
Mart, M-A-R-T.
Data mart. Okay, very good question. So okay, so data warehouses, right? They've got all the data. Now, let's say if you've got let's say if you've got 5 different IT systems, all the data from those 5 IT transactional systems comes into the data warehouse. That example, that includes finance data, that includes customer data, that includes product data, right? It has pretty much all the data you can imagine because everything is consolidated in one place. Now, the way business works is there are different business teams. So, like for example, the finance team doesn't need to know, what is the details about the customer, which customer, what type of customers are buying what type of products. The purchasing, the procurement department needs to know that. They need to run those type of reports. Finance is more concerned about, okay, which store is performing well, which store is not performing well. How much is the number? Are we increasing and so on? So the type of reporting and questions the financing team has would be different from what the procurement team has. But all the data resides in data warehouse. Now, if they're all trying to do this reporting and everything, they easily get confused because it's too much data. They will like, I don't know where to get this data and which tables should I use. So it's very confusing for them. Plus, it's impacting the performance of this data warehouse as well now because multiple teams are running these concurrent queries as well. So in order to solve for it, an extension of it, remember we moved the data from ODS into data warehouse. Now from data warehouse, you create another mart for those business users, for those business teams, in which you are creating a data model which fits for their business needs. So how you model in a data warehouse, right? There are different ways you can model the data in a warehouse. There are 3 ways. One is a star schema, one is a snowflake schema, and the third new way of doing it is called as a data vault. We'll cover that in subsequent sessions, the difference between a star schema and a snowflake schema and data vault. But essentially, that's how you model the data in a data warehouse. So when you're creating a data mart, you're creating the structure of your data in such a way which is very friendly to those business teams to be able to do the reporting. Because when you're when you're structuring your data in a data warehouse, there's something keywords for you to understand is facts and measures. So you're creating the structure of your data model, which consists of multiple dimensions and facts. A simple example of dimension is time. How is my customer purchasing different products over a period of time? So time is always an important dimension. Sales is core, right? Or how much sales did I do in a particular store? So store becomes a dimension, right? So you have different dimensions through which you can slice and dice the data. And the store says, okay, this is a high performing store. Now that's a fact, which is nothing but, sales is a fact, and the measure is high performing store or low performing store. That is a data attribute associated with that fact or that central entity which connects the multiple dimensions. I went through it fast, but don't worry, we'll cover it in more detail. But essentially, data mart is more of a subset of your data modeled and designed in a way which makes it friendly for specific business teams to consume the data out of the data warehouse. Did I answer your question?
Yes.
Okay, good, but good. Glad you asked that. Okay. Any other questions? Okay, if not, we'll cover mind empowerment technique, and we'll shift to a mind enlightenment technique as well. So, mind empowerment technique is how to control our anger, because we all have anger management problems, whether we accept it or not. Because many times we think anger management is someone who really shouts out loud. But reality is, anger has different forms. Anger is not just shouting out loud with a red face. But if someone says something and you're giving bad wishes and you're not saying it with your words, but internally you're abusing that person with all the expletives, that is also a form of anger. The other person cannot see it. They may catch your bad wishes and get those bad vibes from you, but internally it is a form of anger because it's burning within you. But anger also has other subtle forms where if you don't like something, then you will just give that dirty look to someone. That dirty look is also nothing but an expression of anger. So if someone says I have no anger management problem, is basically they haven't done an introspection to know what is the extent to which we've got anger management problems. The question is, are we managing it well, or are we freeing ourselves from anger? The word anger management is actually incorrect, because what we truly need is anger free, right? The word danger and anger, there's only one difference: D. You remove the D, then it's just anger, right? So we don't need to manage our anger. We need to be absolutely anger free. Those are the kind of goals we want to pursue to be a better person, to be able to, we talked about making a better place, a better world where we are giving best wishes. So we don't need to just manage or control our anger where we are not saying anything on the person's face with words or anything, but internally we are seething with anger. That is not anger management. That is just basically, you're avoiding the situation, but the problem still exists. So we want to focus, how do we be anger free, right? That is the true way to really manage the anger, is eradicating or being totally free of anger. So step one, understanding what form of anger exists within us. For example, I get impatient and then I get angry. Now, there's no justification that because I'm impatient, I get angry, no matter what the reason is. Sometimes we'll say, well, I have to scold this other person for their own benefit, no matter whether it's a good cause or a bad cause or whatever the justification is. Anger is just one word short of danger. Simple. No matter what the justification. Many times parents will scold their children because it is good for them. So they justify anger because it's for the good of the other person. In reality, that good for that other person, that good never happens, because the other person doesn't perceive it the same way, that this is for my own good. And they build that resentment. So the good intention with which that anger is executed, it never achieves that end objective. So it's just a false myth, or it's just a false justification to justify that anger. So step one, we need to introspect and understand what form of anger exists within us. We all have it. If someone says, I'm totally anger free, well, maybe, but there are instances when it will trigger it, right? So we need to introspect it, because anytime you want to bring positive change in yourself, the first thing you need to do is acknowledge. And there's a AAA formula. If you don't acknowledge, if you don't accept, you cannot act on it. So the first thing is acknowledge what subtle forms of anger exist within me, right? That's one step. Specifically identify the situations. And what's interesting is, just like how we do data analysis and we find repeating patterns and trends, if you were to do that introspection and do that analysis, you will find there are repeated patterns or behaviors in which you are getting angry. And we try to justify it that, oh, because this happened, that's why I get angry. No matter what the justification, identify instances, specifically the repeated instances where your anger is triggered. Yeah. Acknowledge and accept. We have that problem, because if you don't acknowledge and accept, you're not going to do anything about it, because why solve something when it's not a problem, right? Third step is then, how do I eliminate anger? Not manage it. Eliminate anger, right? We should say anger elimination course, not anger management course. How do I eliminate that anger? The opposite of anger is sitting in silence, right? Now, silence. So, step one, if someone is angry at you, right? Step one is you be silent. Now, initially, internally, you won't be silent. The traffic of thoughts will multiply when you are angry, right? The supply of your blood flow will automatically increase when you're angry. That's why the person becomes red faced, because the blood vessels, they're dilated with the extra blood flow. So initially you won't say anything, but at least that's a positive improvement, because it's a step in the right direction, but it is not the final step. It's not sufficient. Next step is you're not only just containing it with words, but you're actually transforming it at the thought level. When you start doing the analysis, you will notice those trigger points. The first time that situation occurs, if you're analyzing those repeated instances, when the first time that situation occurs which triggers your anger, then and there itself, divert with a positive thought. It's okay, right? People make mistakes. It's okay if the other person makes a mistake. Forgive and forget. I've made a lot of mistakes as well, right? That moment itself, you transform that negative thought into a positive thought. It's okay, right? Then it's a lot easier to not only just be silent, but we want to take it to the next step where you're not only forgiving that person, you're wishing them well. Now, many times people struggle with that concept. How can I wish well to my enemy? That's exactly what you need to do to get rid of that anger. Because the first thing anger does is it burns within you. Whether it destroys your enemy or not, that's secondary. The primary person who's suffering is you. Every time you recollect that incident and you replay it in your mind, that anger will burn within you. And who does it burn first? You. So you have to acknowledge and accept that anger is causing harm to you, to your health. It's a waste of time, and it is not good for your health. And it is not something that who you are, you want to be. Your natural state is loving. Your natural state is peace, just like that of a child. Even if your parents have, some relatives who you are arch enemies with, you absolutely can't stand each other. But if there's a newborn in their family, and when you hold it, the newborn doesn't have any grudge because it's in its natural state. It's in that loving state. It's in that peaceful state. It will smile at you. It won't say, well, my father did this to you, or your father did this to my father, so I'm not going to smile. The child never says that, because its natural state is love. It doesn't care about those trivial things in life. So it's just going to forgive and not even be aware of it. It'll be to its natural state. So the more you wish well for your enemies, if you have enemies still, every day in the morning, wish them well. Try it and let me know how it works. It does work perfectly fine. Specifically for your enemies, right? You immerse them and say, I really wish the best for you. The moment you start doing that, you free yourself of that anger. So now you eradicated that anger which was burning within you and causing you harm, but you gave that best wishes to that person, but internally you healed yourself, right? So that way, step by step, eventually you can be anger free. But the first step is being observant and look within to know where the problem lies. Not if the problem lies, but where the problem lies. And if you were to be able to do that, I'm sure you will know the outcome of this would be a lot more harmonious relationships, no matter whether it's inside, whether at work, no matter what it is. You will be able to deal with all different kind of personalities because you got nothing personal against anyone. You know yourself, you have no enemies, right? If other people hate you, that's fine, that's their job. But you don't hate anyone. That way you'll free yourself and you'll be taking your life to the next level. So I hope you find this mind empowerment technique making a difference in your life as well. Okay, with that we can conclude our session for today. Again, my apologies for keeping you waiting. We'll share more techniques next week. Thank you.
Thank you.
Thanks. Bye.
Thank you, brother. Om Shanti.
Thank you.
Thank